So now, if you're viewing this object, you see, this same object, depending on the position that you're standing in and the angle at which you're viewing this object, we all will see different images. So what that means is that if you should view this truck or this object, it's a truck in this this example. We are viewing this object directly at 90 degrees. That is what you would see. But if a person should stand to the right of this truck or to the side of this truck, that is what they will see. Are we not looking at the same truck? We are looking at the same truck. However, the views of this truck are going to be different. In orthographic, we are going to have to draw each of these views separately. However, we must have a correlation. So what that means is that, let me just draw a simple figure on the board right now. That is my figure. And that is the front elevation. Yes? Directly in front, that is what you would actually see. Now, if you pay close attention, I'm just going to project lines because I want to show the correlation between different views of the object. If I should project lines down, the width of the object will not change. So from above looking down, you can still see this width. Is that clear? We also need to know how far back this goes, the thickness of this object. But from above looking down, we cannot see the height. So we have to have more than one view. So look at this now. In this case, if you are given that measurement, it is easy for us to put this view together. Now please pay attention. The correlation between the different views. Now if we should project a line at 45 degrees this way and 45 degrees that way. Yes? We are able now to project lines across here from the given views, across from the plan, to intersect this 45 degree line. We are then going to be expected to project these lines up. By projecting these lines up, these across, these up, so these across are horizontally. Wherever they intersect this 45 degree line, we project them up vertically. If you notice, we have captured and transferred this same width. So this same measurement here is the same distance between these two lines. And we can do this a similar action on the opposite side. Pardon my lines for not being straight, I am somewhat exhausted. Well, let us continue. So we are going to then project lines across here and lines across there. Notice that the front elevation, the height of the front elevation and the height of the end elevations are going to have to be similar to each other because it is the same object. Is that clear? So all the elevations are going to be on the same height. So we're going to just project this line across, Notice that we have a break here. Is that clear? So we're just going to project this line across and project this line across. Is that clear so far? Now, understand that this, based on the fact that we are going to discuss in detail first angle and third angle. But for now, I am just going to pay attention. I want you to just pay attention to the drawing. Now, I am just going to go ahead and brighten what you would see. If you should stand over here, looking at this object, you will actually see the outline of the thickness of the object. Yes? You could also see the height of the object. And you can see the break. Standing from here, looking this way, you can see the break here. So I'm just going to put that in solid. One solid line. Yes? Over here now, standing over here, looking in that direction, this is what you'll actually see. Notice I have drawn them on the opposite side. I am going to explain that in some detail in a few. So, standing over here, looking here, there is a break on the opposite side of the object, but we cannot see it because it's a solid object. So we have to put this now in what is called hidden details. Is that clear? So this represents the right end elevation. Notice it is drawn to the left. And this represents the left end elevation. Notice it is drawn to the right. This is the front elevation. And this, my friends, is the plan. Okay, now earlier I explained to you that in orthographic, yes, we have two different types of drawings that we need to focus on. Now, there is what is called first angle projection, and there is also third angle projection. And this part of the class you need to pay close attention because we are going to differentiate between the two. So, in an effort to explain this as easy as it gets, we are going to just draw one vertical line and one horizontal line. Now, over here, we're just going to call here 1ST first, and we're going to call here third. Let me write it so you can see 1ST for first angle and 3 RD for third angle. Now, the difference between first angle and third angle is what we want to focus on right now. Alright. Now good. Now if you notice, we have one vertical line here that represents the vertical plane. Consider it as a mirror. And we also have a horizontal line that represents the horizontal plane. So if an object is placed here in first angle, if it is placed there in first angle, when you're standing in this position, yes, looking in this direction, yes, whatever you see is projected on the vertical plane. If you should stand above this object looking down, whatever it is you see is projected on the horizontal plane. That is it for first angle. However, in third angle, if you should place this same object here, so let me just rub out the word, put it here, so it's the same third angle. If you should place the same object or a similar object here, yes, this object, if you view this object directly from this side, standing in this position, looking in that direction, whatever it is that is projected will be projected on the vertical axis or vertical plane. And if you should view this object, understand that you must view in the direction of the plane. Is that clear? So you can't stand here, look down. You have to view in the direction of the plane. Whatever it is that is projected now is going to be projected onto the plane here. Notice that in first angle, we are standing in that direction, looking this way. We have our vertical plane and we have our horizontal plane. Over here, we have our horizontal plane, and below it is our what? Our vertical plane. What that means is that when you're drawing on your paper, you have a flat paper drawing on to represent these lines. Now there's a point of intersection between planes. This is a horizontal plane, this is the vertical plane. So in third angle, this is the section that we are focused on. In fourth angle, if we were making mention of fourth angle and third angle are similar to each other. First and second would be similar to each other. So we only focus on these two names, first angle and third angle. Notice that this vertical plane is above the horizontal plane, which means in your drawing, when you're drawing in first angle, your elevation should be at the top of your paper and your plan be projected below it. Is that clear? In third angle, however, it is the complete opposite. Your front elevation is at the base, yes, which is below. If you notice, it falls below the horizontal plane. So when you actually draw it on your paper, you're going to have to draw your plan at the top. I'm going to explain that in more detail right now. So now, in order to ensure that we all understand this thing, it is best if we put this thing in somewhat of a three-dimensional view. So let me just go ahead and try my best to assist those who are still not yet getting the concept. So I'm just going to draw one line here, another line here. Pay close attention. So I'm going to draw this and draw this. I'm going to draw this and draw this. And then I'm going to close it off. Now, by doing that, what I have done now is to draw the different planes. in a three-dimensional view. So watch this now. This right now represents the vertical plane. Is that clear? This is also a vertical plane, but it is a side view. It is a side view of the object. So it's also a vertical plane. So let me just label it as such. And this now is the horizontal plane. Horizontal plane. Now notice, this represents the same thing that is happening here. Vertical plane over the horizontal plane. Vertical plane over the horizontal plane. Is that clear? So we'll focus right now on first angle. So I'm going to go ahead now and draw an object. An object, yes. Let me draw a box. So by drawing this box, this represents the figure that we are discussing. So let me just remove these excess lines. Yes? Because we can see through the figure. And I'm just going to go ahead and shade this slightly so we are better able to see the figure itself. So that is the object that we're actually viewing in front of these planes. What that means is that if you should stand here and look in that direction, we are going to project, yes, an image onto that plane. Is that clear? So all this is saying is this bam, 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 bam. So that is what you are seeing on the vertical plane. If you should view this object from this direction, it is going to be projected on the plane behind it. Is that clear? That is all. So we're just going to go like this. Notice that the lines should be parallel to each other. Yes? And that is what we are actually seeing. That is what we see. And if you should view from above, looking down, yes? Bam, bam. You're supposed to be seeing an object similar, or an image similar to that of the top that you're seeing there. And that is it. So in first angle, we have our front elevation being projected above the plan. Is that clear? Our front elevation being projected above the plan. What is seen from the left is drawn on the right. And vice versa. If we're standing over here and this plane was on this side, what we would see from over here would be drawn over here. And that is the fundamentals as relates to first angle. And it is the complete opposite if we are doing in third angle. So if this plane was down here, this vertical plane, this same vertical plane was down here, and our image was here. Our figure was here. Our figure was here. If our figure was here, the plan would still be projected here. The elevation, however, would be projected on this side. Is that clear? If you notice now, the plan at the top and the elevation below it. The plan at the top, yes, plan at the top, elevation below it for third angle. And for first angle, we have our elevation at the top and our plan at the base. And that is it. So, students, it is imperative that we all understand all the fundamentals as relates to the topic orthographic projection. Now, I have given you, I have sent to you some exercises for you to complete, and you are going to present those on Google Suite as well as Smart Turf. Go ahead and present those, and remember we have our WhatsApp group. We also have the platform in Google Classroom that we can go ahead and ask our questions, and please ensure that your questions are presented in the groups so that other persons who have other concerns or similar concerns are able now to get those clarified and all misconceptions cleared. Is that clear? Now, just a recap, quick recap. We have our front elevation, our plan. Left end elevation, if you notice, in first angle, it is drawn on the right. So the moment you see a drawing, any figure that is given to you, and they tell you that the drawing at the top is our front elevation, that simply means that this drawing is in first angle. Once the elevation is at the top, this drawing is in first angle. If the elevation was at the base, however, these two elevations will be beside it. All elevations go together, and the plan will be at the top. That would give you a third angle drawing. And that is that. Any questions, any queries, feel free to link up Mr. Campbell or Mr. Myers.